Hi there and welcome to this video on averages from grouped data. Today we're going to be considering how to find the mode, median and mean of data that's given to us represented as a frequency table and grouped frequency tables. Let's start with the mode and median from a frequency table then. In this example, we have Rosie. She's got 10 boxes of drawing pins. She counts the number of drawing pins in each boxes and gives the information in the table below. We read this table as follows. 2 of the boxes had 29 drawing pins in each. 1 of the boxes had 32 drawing pins in. We can use this information then to identify the modal number of drawing pins. Remember, the mode is just the number that comes up most often. So I look at the frequency. The frequency is telling me how often something is occurring. So if I want the mode, I want the highest frequency. I can see that the highest frequency is 5, but 5 is not my mode. 5 actually corresponds to the 30 number of drawing pins. So 30 drawing pins is my modal number of drawing pins. The biggest mistake people make here is just writing down the highest frequency. They don't relate it back to what that's actually measuring. To find the median, I first of all need to figure out how many boxes of drawing pins Rosie was looking at. It tells me that in the question. She was looking at 10. But if it didn't, the way I would find that out is just to add these frequencies. 2, add the 5, add the 2, add the 1, gives me 10. So I can see she was looking at 10 boxes of drawing pins. If she's looking at 10 boxes of drawing pins then, to find the drawing pin or the box of drawing pins that's right in the middle, I have to add 1 to that and divide it by 2. That gives me, technically, the 5.5th box of drawing pins. Basically, it's the one that's in the middle of the 5th box of drawing pins and the 6th box of drawing pins. So let me try and find those two values. To do that then, I need to think about where my boxes of drawing pins are lying within this table. Look at the frequency. I can see 2 boxes of drawing pins had 29 in them. So I know the first 2 boxes of drawing pins both had 29 in them. The next group says that there were 5 boxes of drawing pins that had 30 in them. If I was to write that out as an actual list then, I would write 30 5 times. Now I can see that I've got the first 7 boxes of drawing pins, so I've definitely come across the 5th and the 6th. So the 5th box of drawing pins had 30, and so did the 6th, which means the one in the middle of them two would still have 30 drawing pins. Let's try another one. Andy did a survey of the number of cups of coffee that some pupils in his school had drunk yesterday. The frequency table shows these results. Remember, to find the mode, you're looking for the highest frequency. Looking in the frequency column, then I can see that the highest frequency is 8. But remember, don't write 8. That isn't the modal number of cups of coffee. You have to relate that back to what it's measuring. The modal number of cups of coffee is 5 cups. To find the median, I need to figure out how many pupils Andy surveyed. It doesn't tell me that in the question this time. So to find it out, I'm just going to add the frequencies. 1 add 3 is 4, add 5 is 9, add 8 is 17, add 5 is 22. Andy asked 22 pupils. To find the median pupil then, I add 1 and divide by 2. This gives me the 11.5th pupil, which means I want to find the 11th and the 12th pupil. Let's start listing them then. 1 pupil only had 2 cups of coffee. That would just be 2 written once then. A further 3 pupils had 3 cups of coffee. So that's 3 written 3 times. A further 5 pupils had 4 cups of coffee. So let's write 4 5 times. Have I got the 11th and 12th yet? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've only got 9th pupils and I need 11th and 12th. So I definitely need those ones in the next category then. So 8 pupils had 5 cups of coffee. So I'm going to write 5 8 times. Now, it's not wholly necessary that you write these out. I'm just demonstrating exactly what the underlying table is representing. You may be able to do it without writing them. Now I know that the 11th pupil had 5 cups of coffee and the 12th pupil had 5 cups of coffee. So therefore the median is 5 cups of coffee also. Let's try these quick questions. You'll have 5 seconds, but if you need longer, just pause the video and press play when you're ready for the answers. What's the modal number of siblings? Remember, for the modal, look for the highest frequency. The highest frequency here is 14, and that relates to having 1 sibling. So 1 is the modal number of siblings. The table shows the shoe size of learners in 10C. What's the median shoe size? First of all, let's find out how many students there are in 10C. Add the frequency column. 2, 6, 9, 12, 17, 21, 22, 23 pupils. So if there's 23 pupils, I add 1 and divide by 2. That means I'm looking for the 12th pupil. The first 2 pupils are here. The next 4 are there, so I'm up to the 6th pupil. The next 3 pupils, so now I'm up to the 9th. The next 3 pupils are there. Now I'm up to the 12th. So my 12th pupil lies in this category. They have a shoe size of 7. 7 is the median shoe size. Try another median question. Find out how many people were asked in the table. Add the frequencies. 6, 13, 14, and 15. There were 15 people asked. If there were 15 people asked, add 1 and divide by 2 to find the median. That would be the 8th person asked. The first 6 people are here, but that's not enough. If I ask the next 7, I'm up to the 13th person. So the 8th person is definitely in this category. They had 1 sibling. So therefore the median number of siblings is 1. Now on to finding the mean from a frequency table. I'm going to use the same tables as I did before, but this time to find the mean is a little bit of a different method. Remember, the mean is adding them all together and dividing by how many there are. So I definitely need to know how many is in the table. To find how many, you always add the frequencies. In this table then, it gives me a frequency total of 10. Now I need to find that how many there are. So 2 boxes had 29 drawing pins. In total then, those 2 boxes had 58 drawing pins amongst them. I got that by multiplying them together. If I multiply the 30 that were in 5 boxes each, I've got a further 150 drawing pins. 2 boxes had 31 in each, so that's a further 62 drawing pins, and 1 box had 32 in, so that's a further 32 drawing pins, which gives me a total drawing pins of 302. Now I have my total number of drawing pins and I have my total number of boxes. So to find the mean of drawing pins in each box, do 302 divided by the 10. It gives me 30.2. We normally then round this, as you can't get 0.2 of a drawing pin. So I would represent this as both numbers. The 30.2 I first worked out, and then that's rounded to 30 drawing pins to the nearest drawing pin. Let's look at another, again with the cups of coffee. 1 pupil drank 2 cups of coffee, so that means they had 2 cups of coffee in total. 3 pupils drank 3 cups of coffee each, so that's 9 cups of coffee in total. If I go down the table just like this, I can find the total number of cups of coffee that were drunk by all of the pupils. Now I need to add two of my columns. I add the answers that I've just multiplied and add the total frequency. You never add the first column of what it's measuring. This gives me a total of 101 cups of coffee that were drunk amongst 22 pupils. So to find the mean number of cups of coffee per pupil, do 101 divided by 22. This gives me an answer of 4.6 to one decimal place, or rounded to the nearest cup of coffee, that would be 5 cups of coffee. Try and find the mean number of pets from this table. Multiplying across then, we get the following answers. 0, remember 0 times anything always gives you 0. That's a big place where people make mistakes on these. 3, 4 and 9. Therefore, the total number of pets is 16 and the total frequency is 10. 16 divided by 10 is 1.6. So the mean number of pets is equal to 1.6 here. If we're rounding it to the nearest pet number, you could also write 2. Try and find the mean number of spots per ladybird. Multiplying across here, we have 15, 24, 84 and 8, giving a total number of spots of 131 and a total number of ladybirds of 20. So the mean number of spots per ladybird I would find by doing 131 divided by 20. This gives me 6.6 to one decimal place. Try and find the mean score for each teams here. Multiplying across then, I can't do just yet because it's not actually given as a frequency table. It's given as a frequency diagram. So the first thing you might want to do is convert this information into a table. I can see that 2 teams got a score of 5. I can see that 5 teams got a score of 6. So I can go on and down like this. 1 team got a score of 7, 2 teams got a score of 8, and 1 team got a score of 9. No teams got a score of 10, so I don't need to write that in my table because when I multiply it, it would be 0, and when I'm adding it to my frequency, it won't add anything on anyway. The answers I get there then are 10, 30, 7, 16 and 9, giving me a total score of 72 amongst the 11 teams that took part. 72 divided by 11 would give me 6.5 to one decimal place. Now sometimes data is grouped within a table. In this table, we have the temperature groups 10 to 12, 12 to 14, and so on, apart from some of them use different inequality symbols. This group is read that the temperature is bigger than or equal to 16, but smaller than 18. So can a number in this group equal 16 exactly? Yes, it can, because we can see the lower end of the groups, it can equal it. But a number of 18 cannot fit in this group because it's anything up to, but not including 18, anything that's strictly smaller than 18. 18, in fact, would go in the next group, 18 to 20. Let's do some quick questions then, testing where we're going to put certain numbers. Which group then, A, B, C, D or E, would the group 17 belong to? Yes, that would be in group D. Where would 13 go? Group B. Where would 14 go? Group C. Well done if you said that. 14 is allowed to be included at the bottom end of Group C, but it's not included in Group B. Where's 18? Group E. Where's 16.4? Group D. Where's 14.3? Group C. What about 10.3? Group A. And 18.1? Group E. We can use grouped frequency tables then to calculate the mean temperatures as well. First of all, I want to actually find out how many of these temperatures are in this table. Have a go at creating your own tally chart. Put each of the temperatures in where it should go. For instance, 16.4 should go in this category. I'll put one tally there. Once you've done all the tallies, just write the number of how many is in each group in the frequency columns. Pause the video, have a go, and when you're ready to compare tables, press play. Here's the table you should have then by transferring those temperatures into the tables. We can use this group frequency table to find an estimate for the mean. It will always now only be an estimate because I do have to estimate what the temperature is in each of these categories. I do that by finding the midpoint, or the point that's in the middle of the groups. My first group is 10 to 12, so the midpoint there is 11. If you're struggling to find what the midpoint is, just add the two endpoints, 10 plus 12, that gives me 22, and half it. The other midpoints then are as follows: 13, 15, 17, and 19. Now I have a midpoint estimate, I can go ahead and multiply just as before by using this new midpoint estimate. This gives me 33, 91, 180, 102, and 38. When I add them, I get 444. And remembering to add the frequencies as well gives me 30. So 444 then, divided by 30, gives me an average mean temperature of 14.8. That's measured in degrees Celsius, as indicated within the table. Let's try another one. Here I have 80 people's salaries that work in Jenny's factory. I want to find the mean average of the salaries paid to these 80 workers. So find the midpoints. The midpoint between 10,000 and 14,000 is 12,000. The midpoint between 14,000 and 16,000 is 15,000, and so on. Do place close attention to these groups because some of them do change. They don't always follow the same pattern. Now I can go ahead and multiply these amounts. I get the following numbers: 384,000, 360,000, 272,000, 114,000, and 60,000. When I add all of those salaries, I get 1,190,000, which is amongst 80 workers. It says so in the question, but I could also find that by adding the number of workers. So if I share that 1,190,000 amongst the 80 workers, it gets me a mean salary of 14,875. Here you can see that that mean salary has been really adversely affected by the fact that it's got some really high earners in this category, when in fact the majority of workers are actually below 14,000. That is one downside by using the mean. It can be affected by extremely large or small values adversely. Time for you to have a go. Pause the video, and if you need longer though, when you're ready, just press play. What's the midpoint of the group 15 to 22? Remember, if you're struggling to see it, add the two endpoints. So 15 add 22, and then simply divide it by 2. This gives you a midpoint value of 18.5. Which columns must you total up and divide by here to calculate an estimate of the mean? Okay, so when you have your midpoint, you times it by the frequency. Here's my answers for them. So it's this one that I need to add. And then I also need to divide by the total frequencies. So it would be column 4 divided by column 3. Have a go then at finding the mean of this group data. Okay, the midpoints I get for these then are as follows: 5, 15, 25, 35, and 45. Multiplying those across, as we've always done before, we get the following answers: 15, 120, 275, 315, and 405. Adding all of that, I get 1,130, and my total frequency is 40. So 1,130 divided by 40 gives me an answer of 28.25. That's brought us to the end of working with averages of frequency table data and grouped frequency table data. Now try all the question sets to explore this topic a little bit more. Thanks for watching.